A junction diode is used in most types of electronics like chargers, mobile phones, televisions, and so many other gadgets. In a layman's understanding, let's just say that it is a device that is used to ensure current passes in one direction. For example, all solar cells are junction diodes. Getting into the details of the junction diode will be for another session, but for now, I want to concern myself with voltage-current relationships of a junction diode coming up. So here is our experiment that we are going to be using to investigate the voltage-current relationship of a junction diode. The experiment is set up as we can see. We are having a resistor right there, a switch, a cell, a milliammeter in this case because we are measuring very small currents. We can't use an ammeter, but a milliammeter because it's measuring very small currents. Our junction diode is right there. Sometimes this junction diode is also referred to as a semiconductor diode. And then we're having our voltage. This voltage is connected across this junction diode so that we are able to get the potential difference across the junction diode or the semiconductor diode. And also this milliammeter is meant to find the amount of current that is going through. Since our experiment is that we are supposed to find the voltage current characteristics of the junction diode or the semiconductor diode. Our setup here is very different from our previous experiments because the current values here are very small. Then we have a sliding contact onto this, a sliding contact. So what we do to be able to get the different values of current and voltage, we are going to adjust this sliding contact. So we adjust this sliding contact. Wherever we adjust it, we get different values of current and voltage. When we adjust it, we get different values of current and voltage. When we adjust it again, we get another value of current and voltage. Now, while we are getting these different values of voltage and current, we put them in a suitable table. Of course, our table is going to involve a column of current and voltage. Then when we get the values of current and voltage after adjusting our apparatus, we are able to plot them on the graph, and we're able to get this kind of graph. And from this graph, we are able to see definitely that the voltage current characteristic of a junction diode is a non-linear one, and this definitely means that this is a non-ohmic conductor. The values of current below zero are obtained when the diode is reversed. So take note that such currents are very small.